Hi everyone and welcome back to this trigonometry lesson, and finally we are ready to use our trigonometry ratios to find the missing sides and angles of a right angle triangle, because now you've learned all the tools to do so. Now when you have one side and one angle, we can calculate another side. So here I've got one side and an angle, and I can calculate any of the other two sides. Okay. Before, if we had two sides, then we can use Pythagoras to calculate the third, right? But now we don't. So that's where the trigonometry ratios come in. So how will we get the third angle in this triangle? Well, easy, right? The interior angles of a triangle, and smiley face, because we tend to forget about this. If I have two angles, then I can get the third. But the question is not to calculate the third angle. We actually want to calculate the length of AC. And then if we have it, then we can use Pythagoras to calculate BC, but not for the purpose of today. We are going to calculate BC also with the trigonometric ratios. So let me show you how this is done. First of all, I'm going to show you with my index finger and thumb again. So basically, if that is my 90-degree angle, my index finger here is the base and my thumb is the height. So AB is the hypotenuse, right? So let me write that down. So this will be my hypotenuse. Okay, and I can put my hand away now. There we go. So now we have this angle and we want to use this to calculate the length of AC. So basically I'm going to look from this side, and if I continue, the side on the opposite side of the angle will be my opposite, right? So this is my opposite side, and that means that this one will be my adjacent side. Okay, great. So look what I do now. I want to calculate the length of AC. So I have the hypotenuse and I don't have AC. Forget about the adjacent for now because I don't want to calculate it. So what ratio do you know that deals with the opposite and with the hypotenuse? Isn't it the sine? Yes. So basically the sine of 35 degrees is equal to the opposite side divided by my hypotenuse. Okay, great. So now that we know this, we can simply say that the sine of 35 degrees equals, what is my opposite side in terms of the triangle? It's AC. So we can say AC divided by my hypotenuse, and my hypotenuse is AB, but we have the size, which is 8. So AC divided by 8. Okay, great. So now I have an equation that has a fraction in it. So basically, we can just multiply straight through with the LCM of the denominators, which is 8, right? So this side will become the 8 times the sine of 35 degrees equals, and then remember, if the LCM, and I'll write it here on the side, if the LCM is 8, so basically 8 divided by 1 is 8 times the sine of 35 degrees gives me 8 times the sine of 35 degrees. And 8 divided by 8 is 1, and 1 times AC is AC. So we can calculate AC by doing that on the calculator. So basically I just say 8 times, or just 8, the sine of 35 degrees, close the bracket off, and you will see that we get an answer of, and let's round it off to 2 decimals, so 4,59 equals AC. So it will be basically 4,59 centimeters, and we can fill that in here. So that will be 4,59 centimeters, and there we go. Now, how about we calculate BC? Now, to calculate BC, we are going to use the length that they gave us and the angle that they gave us. So which trigonometric ratio do you know that deals with the adjacent and the hypotenuse? Isn't it the cosine? So the cosine of 35 degrees is the adjacent over the hypotenuse. So let's write that down. So the cosine of 35 degrees is equal to my adjacent divided by my hypotenuse. And that will be my adjacent side, which is BC, divided by my hypotenuse, which is 8, right? So then to calculate BC, again, it's the cosine 35 degrees and BC divided by 8. There is a fraction in this equation, so we're going to multiply all the way through with the LCM, which is 8. So this will be 8, the cosine of 35 degrees, which is equal to BC. And if we type that into our calculator, I just simply type the 8. Then I press the cosine button, I put in 35 degrees and I close the bracket on the calculator, and then we see that the answer is to 2 decimals 6,55 centimeters equals BC. So this will be 6,55. Okay, brilliant. And because we rounded off, you can go and test it by doing Pythagoras, and you will get answers very close to this. But remember, we rounded off, right? So the answers that you will get with Pythagoras will be very close. But you need to know how to use your trigonometric ratios. It's not that hard, is it? Okay, let's go and try some more examples. Now in this example, we are going to use our trigonometric ratios to find the missing angles in this right angle triangle. So when we have two sides, we can calculate any angle. Now here we have two sides, so we can calculate any one of these two angles. And once we get one of them, it's easy to get the third. We just use the interior angles of a triangle. But to explain the following to you, I'm going to calculate angle B and angle A using the trigonometric ratios. So first of all, I'm going to use my thumb and my index finger again just to find my hypotenuse in my right angle triangle. So if I put my hand there, I have my index finger pointing to my base and my thumb to my height. So we know that AB is my hypotenuse. So I'll write that down. Okay, this is the one that actually never changes. Now I can put my hand away, there it goes, and now I can calculate angle B. So let's start. Now if I want to calculate angle B, that means I want to look from this side. In other words, if I look at this triangle from this angle and I keep looking straight ahead, this side is opposite my angle, right? So this is my opposite side. So let me write that down in red. So this is my opposite side for angle B, and this will be my adjacent side for angle B. Okay, so I'm busy calculating angle B. Now here we have two sides and I want my angle. So we are going to use these two sides. Now what ratio do you know that has an opposite side and an hypotenuse? It's the sine of this angle, right? So let me write that down. So the sine of angle B equals my opposite side divided by my hypotenuse. And in this case, it will equal to, and then we know that our opposite side is 5 centimeters, so it will be 5 divided by, and here we know that the hypotenuse is 8, so divided by 8. So now I know that the sine of angle B is equal to 5 over 8. So I have the ratio of the sides, and you know how to calculate this from our previous lesson. So basically, if we just want the angle left, so just angle B, what do we have to do with this coefficient sine? We have to divide with it on that side, but we cannot divide with sine. We are going to write there that it's the sine to the power of -1 and then 5 over 8. And then I know that my angle B is equal to, and then we can just simply type all of this into our calculator. And please remember, if you want the sine to the power of -1, we use shift and then the sine button, and then you basically put in the 5 over 8 in the brackets, and then you close the bracket on your calculator. And then when you press equal, you will see that this will be 38, and let's round it off to 2 decimals, 68 degrees. And now I know that angle B is 38,68 degrees. Okay, great. So can you see where the previous lessons work comes in when we were dealing with the equations, and when we have the sine of an angle and we have the ratio and we want the angle? Do you remember what to do? Yes, just like we did it over here, right? Okay, now let's continue. let's calculate angle A also using our trigonometric ratios. We can actually use the interior angles of a triangle now to calculate A, but I want to explain this to you. So that basically means that now that we want to calculate A, we are going to look at it from this side. So now I'm not going to have this as my opposite or my adjacent. So basically I'll use blue to show you. So this will now be my opposite side for angle A, because if I continue down this way, BC is my opposite for angle A, right? And that means that AC will be my adjacent. You are right. So this will be my adjacent side. So now, what do you know? Which trigonometric ratio do you know that deals with? Now remember, we don't have BC, so we cannot include that if we also don't have A. Then we have two unknowns in the same equation, right? So we want to make use of the two sides we have. So what ratio do you know that has an hypotenuse and an adjacent side? Well, it's the cosine, right? Because the cosine is my adjacent over my hypotenuse. So now we are going to use the cosine of A. So the cosine of angle A is equal to my adjacent side divided by my hypotenuse. So that means that the cosine of angle A, and what is my adjacent? It is 5. So again, this will equal to 5 divided by, and my hypotenuse is 8. Okay, great. So there we go. And now if I just want my angle to stand alone, I am going to write here angle A. The cosine is the coefficient. So I need to move this coefficient to that side, actually divide with it, but we can. So what do? We write there that it's the cosine to the power of -1 and then 5 over 8. Okay, great. So now let's see what we get here. So my angle A is equal to, and now we press shift on our calculator again, and then we enter 5 over 8 in the brackets on your calculator. We close the bracket off, we press equal, and then we end up with 51,32 degrees if I round it off to 2 decimals. And you can go and test it, because 51,32 plus 38,68 gives me 90, and 90 plus 90 is 180. The interior angles of a triangle is 180 degrees. Okay, easy enough, isn't it? Okay, fantastic. Now, let's continue with the following. I'm just going to put this in for a little bit of extra practice. So we want to calculate BC, and let's assume that we have this angle now, or that was given to us, and they ask us that we need to calculate the length of BC. Now, what we can do is we can identify what this side is in relation with this angle B. Now, if we look from this side again, we'll be busy with the opposite, the red ones, right? And this red one is the adjacent for angle B. So now, if I want to use, or if I want to calculate BC, I want to use the adjacent and the hypotenuse. Let's assume we have the adjacent and the hypotenuse and not that 5 centimeters. So let me cross that one out. Okay, so basically that was the one that was given and the angle, and we want to calculate BC. So what ratio do you know that has the adjacent side and the hypotenuse? Well, it's the cosine, right? So now, if I say that the cosine of 38,68 degrees equals, and then I can say it's my adjacent side, which is BC, divided by my hypotenuse, which is 8, right? Okay, great. Now, so that means that in this equation we have a fraction. So what do we do when we have fractions? We get the LCM of the denominators, which is going to be a 8, because the cosine 38,68 degrees is over 1, right? So my LCM of the denominators will be a 8. So now what do we do with this? 8 divided by the 1 here as the denominator is 8, and 8 times the cosine of 38,68 degrees will give me 8 times the cosine of 38,68 degrees, right? Equals, and then 8 divided by 8 is 1 times BC is just my BC. Now for those of you who want the easy way, because we divide with 8 here, we're just going to multiply with the 8 on the other side if you don't want to use it this way. So now we have the 8 times the cosine of 38,68 8,68 degrees, and if you type this into your calculator, you will end up with 6,25 centimeters if we round it off to 2 decimals, which will be equal to BC, and you are done. Okay, excellent. So keep practicing these, and let's go and try another example. Now here is a very nice example that you can try to see if you understand exactly what is going on in this lesson. Now, remember, you can only use your trigonometric ratios for right angle triangles. So let's see what we have. They say that SK equals 8 kilometers. So SK is 8 kilometers. So let's write that in. That's 8 kilometers. And then they want us to calculate the length of DS, this one. Now, if we just look at this small triangle here, JDS, that triangle, we don't have any other angles and we just have one side. So we cannot use our trigonometric ratios for this, and we cannot use Pythagoras. So let's go and look at the big triangle, because JDK is also a right angle triangle. And here we have one of the other angles, and we have one of the sides. So that means we can calculate another side. So let's think about this. If I calculate DK and I get that for the big triangle, then I can just subtract the 8 kilometers and I will have DS, and that's what they ask me. So we're going to look at this triangle from this side, right? So if I keep looking at it, this will be my opposite side. Very good. So this will be my opposite side. For this angle K here, for the 8 degrees, this will be my opposite side. And DK will be my adjacent side. And then this will be my hypotenuse, right? Okay, so I didn't use my thumb and my index finger for this one, because there is my 90 and I started to learn how to get the hypotenuse, right? But you can always use your thumb and index finger to find your hypotenuse first. Now, we are given the opposite. I cannot use my adjacent because the adjacent is the entire DK. So I'll quickly show you with a green line. I'm talking about this entire line here, okay, which is my adjacent. So now I want to use a trigonometric ratio that has my opposite side and my adjacent side, because I already have this angle. So which one has the opposite and adjacent? It's the tangent, right? So now I can write here that for number 1, the tangent of 8 degrees equals, and then I can say what is the tangent? Is my opposite over my adjacent. So just to show you, it will be JD divided by DK, okay, which will be my opposite over my adjacent for that angle. So this will equal to, so the tangent of 8 degrees equals 5 kilometers divided by DK. Okay, brilliant. Now, I'm so happy about this example because this is a little bit more tricky now, because this is an equation, okay, with a fraction. And here, if we look very carefully, I can put this over 1. So what is the LCM of the denominators? It's DK, right? So the LCM here is DK. It's actually that side. So DK divided by 1 is DK. And DK times the tangent of 8 degrees will be the DK tangent 8 degrees equals, and DK divided by DK is 1 times 5 is 5. Or you can just say, because I'm dividing with DK here, I need to multiply it with it on the other side to get rid of the DK, and that's what we did. Okay, so I'm just showing you the way that we've always practiced equations with fractions. So now we still only want DK. So look very closely, because this is a part that catches learners out. So we want DK, so the tangent of 8 degrees is actually the coefficient. Okay, so now we are going to divide with the tangent of 8 degrees on this side. So this equals to 5 divided by the tangent of 8 degrees. Now some of you will say, you cannot do that. Well, we can, because I'm not just moving the tangent, I'm moving the tangent of 8 degrees. And remember, the tangent of 8 degrees is actually a ratio, right? When we are just moving the tangent, we cannot divide with just a tangent. because then we have to write the tangent to the power of -1. Here I'm actually moving this entire thing, the tangent with its angle. That's why we can divide with it. So now dk is equal to, and now you can type this into your calculator exactly the same way as it is written here. Okay, so we can just say 5, and you can use your fraction button, and then for the denominator you have the tangent of 8 degrees. Don't forget to close your bracket on your calculator after the 8 degrees, and then press equal, and you will see that dk is 35, and let's round it off to 2 decimals, 58 kilometers. Okay, so there we go. So dk is 35. So it's 35,58 kilometers, but we still haven't answered the question for ds. So basically then ds is equal to 35,58 minus 8, and then we will just simply get 27. So ds equals, and I'll write that down, it will be 27,58 kilometers. So now I know that ds is 27,58 kilometers. Now, what's the next question? They want us to calculate angle DSJ. DSJ. So this angle here, and I'll write it in red. So they want us to calculate that angle. Now, that angle is part of the triangle JDS, and we already have DS and we have JD. So we have two sides, and then that means we can calculate the angle. So let's just see what is this side in relation to this angle. So this will be my opposite, and I'll write that in red as well. So the opposite. And this will be my adjacent, and I'll write that in red. So we are referring to the 5 kilometers and the 27,58, right? Because it's part of this triangle, and I'm talking about this angle. So if I follow it, this will be my opposite, and this will be my adjacent. So let's do this. Which trigonometric ratio do you know that deals with the opposite and adjacent sides? Yes, it's the tangent, right? So now I can say the following for number 2, that the tangent of angle, and I have to say here that it's DSJ, equals, and then we know that it will be basically my opposite over my adjacent. So it will be JD divided by DS. And now I can continue. So this will be the tangent of angle DSJ equals, and what is JD? That's 5 kilometers. DS is 27,58. And we just want the angle, so we want the angle to stand alone. And look now I'm just moving the tangent, not the tangent and its angle. So then I cannot divide with it. I have to write the tangent to the power of -1. And 5 over 27,58. So now it's some calculator work that we need to do, right? So we are just going to take this tangent to the power of -1 and 5 over 27,58 and put that into our calculator. So let's do that. Please remember, it's the second function, or the shift of the tangent, and then in brackets you just put in the 5, use your fraction button, and then type in 27,58, and don't forget to close off your bracket on your calculator, and then you will see that angle DSJ is equal to 10,28 degrees. And there we are done. So now I can fill that in there. So that will be 10,28 degrees, and we are done. Now this was an old exam question. I think it was quite a good one, and there's a couple of things that you have to remember in this example, like here when the missing side is actually the denominator in the fraction. Don't forget it. So we have to move it once and then the other coefficient as well, right? And remember, when we move the tangent with its angle, we can simply divide with it. When we are just moving a tangent, we cannot. We have to write tangent to the power of -1. Hope to see you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.